Okay, so let's go ahead and start on that problem number 5. Remember that I said at the end of the other video that this is the first problem where we don't have x equals or y equals a particular number, and we have to take a preliminary step to make that happen. When you're going to look at these problems, the first thing I suggest you do is you look for the x or the y with the leading 1 as the coefficient, or 1, positive 1 as the coefficient. Usually it's invisible. So that in problem 5, it's right here. This first x is the one I want to get all by itself. So to do that, I need to undo or use the inverse operation to 2y. So I'm going to subtract 2y from the left and the right so that I now have x is equal to negative 2y plus 1. This is my substitution step. I changed the second equation, so I need to go back into the first equation and make the substitution, or plug in the quantity. Remember that when you do that, you take the x out and put the quantity in. Other equation. So we start with 20 times x, so times negative 2y plus 1, and then we continue the equation. Minus 30y equals negative 50. We've made the substitution, and now we have a problem with just one variable, so we can solve it with our chapter 4 rules. We do our distributive property first, combine like terms, and solve. Remember that negative 30y is not in the parentheses, so we do not need to distribute to that also. Use your balance line if you need to. That negative 40y and negative 30y are on the same side, so they just get combined. Once we have that y equals, remember that's not enough information. You have to go back up to any of the problems that have both an x and a y and plug it in to solve. So I took the y value out. I picked the easy one. X plus 2 is equal to 1, so that x has to equal negative 1, and that makes my solution negative 1, 1. That's the point where those two lines intersect. All right, I think you're doing pretty well. Would you please give problem number 6 a try? Look for that leading 1 coefficient. All right, so let's go ahead and finish this problem. I take a look at both equations. I look for the variable that has the leading positive 1 coefficient. So first equation has positive 1y. So this is the y I'm going to solve for. So I'm going to take that equation and subtract 2x from the left side and from the right side, so that I now have y equals negative 2x plus 9. That's my substitution. There's my quantity. I'm going to go into the other equation and take y out and put the quantity in. Minus, take the y out, put the quantity in. Because it's a subtraction, you have a distributive property. Be very careful with it. Remember, that means multiply. Combine like terms. Remember, if I get an x equal to a number or a y equal to a number, I always have to go back up to any of the places that have both an x and a y. Doesn't matter which one. Pick the easy one. Hopefully you're getting the hang of substitution when you have one solution. Our last two problems are going to be situations where we have either no solutions or all solutions. So let's take a look at our last two problems. All right, so number 7. Remember, the directions say solve by substitution. So when we do that, we're going to look, and the first, well, there's lots of places where there's easy, but look at this second equation. It's already solved for x equals. So we're going to put our parentheses and call this our quantity, so we don't have to do any extra work. Although there were lots of places where we could do extra steps and still do substitution. But we'll take the easy way out. So we're going to go into the first equation, and every place where we see an x, we're going to take it out and put this quantity in. So that quantity is negative y plus 2. Then we finish the equation. Plus y equals 2. Simplify, so combine your like terms. You have a negative y and you have a positive y. So that makes a 0. So we have 0 plus 2 equal to 2, which is in fact a true statement, right? 2 plus 2, 2 and 2 are the same. So that we end up with a true statement. And anytime we have a true statement, we know that everything will work. So that means that we have infinitely many solutions. And we have the exact same line. In this case, that line is y equals negative x plus 2. Notice the slope-intercept form. You didn't really think you were getting away from that, did you? So a true statement gives me infinitely many solutions, and I have to make sure I tell you, or you have to make sure you tell me which line it is that we're looking at by using slope-intercept form. Now let's look at number 8. So if we've seen infinitely many, we're expecting this one to be, yeah, you're probably right. It probably is, but let's see what happens when we do that. Again, you're looking at this problem. You're looking for that easy way out. The first equation has a y with a positive 1 coefficient, so we could solve that one, but it makes much more sense for us to take the one that's already done. So that we have y equals negative 2x plus 2, that part becoming our quantity. Go into the first equation and plug in 2x plus negative 2x plus 2 equals negative 6. Now notice I didn't put the parentheses in because it was a positive 1, and I would just distribute a positive 1 and rewrite it. So I just skipped that step. Although you don't have to, you could write it out. Positive 2x and negative 2x are going to make a 0. So again, I'm going to have 0 plus 2. This time it's equal to negative 6. And we know that 0 plus 2 is
2.
And 2 cannot equal negative 6. So this is not possible, which means these two lines are parallel. They'll have the same slope, so they'll never touch. They'll never have a common point.